Hi there, I'm Conan, and today I'm going to tell or explain to you a thing or two about parabolic activity or projectile motion. So let's get right to it. So first of all, what is projectile motion? Well, projectile motion is a form of motion in which an object nor a particle called a projectile is thrown near the Earth's surface, and it moves along a curved path under the action and doing of gravity only. In other words, Earth's gravity is the one that's always responsible for its falling nor re-entry back to the ground nor surface. The only force of significance that acts on the object, in which I've said earlier, is of course gravity, which acts downward to cause a downward acceleration. The motion can be split into two components. If u is the initial velocity at some angle theta, the horizontal component of the velocity u cosine theta is constant in this small little diagram in which I drew. Like I said, this is the vertical motion of a moving nor falling object, and this represents the horizontal motion of the moving nor falling object. Like I said, this is the u cos, which is always in the x-axis, and as I said, the vertical component, which is the vertical motion of a moving nor falling object, or in which we can write it down as u sin theta, accelerates due to gravity and changes with time. This acceleration is constant at every point in the flight. The combination of both of these individual motions give rise to the parabolic trajectory. So, in which this dot I've drawn all the way from the starting line all the way to the end of the x-axis, or the horizontal motion of the object, is the object itself, like a ball or a tennis or something else. It can be anything. So the time can be found using the initial vertical velocity, or the u sin theta, and the final at the peak of the flight, which is always zero. And the maximum height can be found using h, the formula that goes h equals u sin theta to the power of 2 divided by 2 times the gravitational force or energy, which is always 9.8 meters per second. And the range can be found using the time of flight and the constant horizontal velocity with the formula that goes r, which is the range, equals u cosine theta equals the time. So, and last but not least, the range formula can be expanded by substituting our expression for time above, which goes like r, or range, equals u cosine theta equals time equals 2 u to the power of 2 times by sin theta cos theta divided by gravity, which is once again always is 9.8 meters per second. So yes, that's pretty much all I've got to say. Thank you very much for listening and watching. I'll see you later.